Hi, everyone. Great to have everybody in this session. Wonderful, wonderful to have everyone here. Great, great, great. So, yes. All right, all right. So there will be too many questions. So it'll be great if, you can have a more brief introduction about yourself in the beginning, and then have very crisp and clear questions for me. Okay, so I'll try to keep things brief, and I'll focus a lot more on the technology side than the ethicality and legality side of things. So I'm going to focus a lot more on the technology side. So here's a brief about this webinar. So I'll go over about CloudxLab briefly, then I'll briefly about myself, and then we'll talk about what exactly ChatGPT. Then we'll start from very basics, like how does a machine learn? Okay. I'll start with very basic, like how does a machine learn and how does a model output a word? And then we'll talk about transformers, attention mechanisms. Then we'll talk about how does a machine output a sentence. And then we'll talk about beam search. And afterwards, we'll talk about the GPT overview. And then there are like multiple models of GPT, and we'll just compare them, as well as the underlying objective and how exactly GPT functions. Then we'll talk about the architecture of ChatGPT, which is based on InstructGPT, and then we'll talk about the limitations of it. So feel free to ask questions, and towards the end, I'll take the questions. Because most of your questions will get answered during the talk. So I'll take the questions towards the end. It's a 2-hour session with 10 minutes break. Except for the speaker, everybody's on mute. So please use YouTube chat to ask questions. We will try to share the recordings and slides with everyone. And yeah, cool. So a bit about myself. I did my BTech or engineering a long back, 2002. And then I worked with companies like D, Shaw, InMobi, Amazon. Also, I founded a company called T-Bits, and now I started a company called CloudxLab. So my personal passions are the software engineering and maths, and I enjoy studying all these aspects, as well as I love explaining complex things in simple manner. I'll try to keep things super simple. It may look like a misrepresentation at points, but trust me, it will be completely okay. So I'll try my best to keep the simplicity without losing its meaning or without causing a misinformation. Okay. Wonderful to have all of you in this session. There are more than 150 people live right now. So great. That's briefly about myself. At CloudxLab, what we are trying to do is we're trying to upskill engineers and IT professionals in deep tech and deep learning. So you can take a look at our platform. So we have this hands-on platform where there's a lab integrated into it, and there are exercises. We believe that people learn by doing, and therefore we have created a learning platform which is more like a playground where you can do hands-on all the time, because the learning starts with hands-on. Nobody learns from only theory. Okay. Then we have like a full environment whereby you can train your models, you can clean your data and all of that. That's a lab. It's an unbridled lab in which you can keep doing your stuff. And with most of the things that are already installed, like data engineering tools, TensorFlow tools, deep learning tools, and so on. So all the tools are already installed, and you can start fiddling around with your data and so on. Also, we have put the data sets on the cloud. So usually when you join a company, you usually get an internal cluster where you do exactly what people do at CloudxLab. And it gives you a seamless experience whereby there's no hurdles, as in you don't have to wait for somebody to start a machine or something like that. And you can connect with most of the devices. And on top of it, as you work at CloudxLab, as in you do exercises and all of that, it keeps on giving you a point and also keep on updating your social profile. And that's fairly popular. Okay, so even if you are not taking a course or something, feel free to make your profile at CloudxLab. And that helps people, that gives you a lot of visibility. Like recruiters keep browsing people's profile, and they usually message each other and so on. So, sorry about it. Now, there are lots of jobs posted, and then periodically we have exams. So feel free to sign up at CloudxLab. And if you're getting emails from CloudxLab, make sure that you mark them not spam. And right, so that these emails about exams and other things land in your inbox. Also, we have a newsletter that in which we talk about the current trends in technology. All right, so without further ado, let's just move on to the architecture of ChatGPT. All right, so briefly, let me talk about what exactly ChatGPT. Like many people have not tried it yet. So it's an NLP model which generates human-like responses in chat, like human-like responses. And it's basically online website by OpenAI. If you search for ChatGPT, you will get the website and you can log in instantaneously and start interacting with it. Let me show you some of the work, some of the past queries that we have done. I have actually done a lot more queries, so I just want to show you this. So here it's giving a marketing strategy, right? So you can ask a question as complex as this one at the top saying, please write a marketing strategy for a new startup that is selling legal software to help managing contracts. I have a marketing budget and need to reach the top 10,000 companies in US. Please provide detailed examples of comprehensive strategy. Now, what you see is, it is as if some very educated person have created this answer. Okay. Now, if you take a look at it, it's actually not just random text. It does carry a lot of meaning, though it may not be very, very innovative, but it is a commonsensical answer that you see here. Okay. Similarly, if like you can write a description for webinar on ChatGPT architecture. So this is something that we had posted. So you can see that it has given a detailed architecture of ChatGPT in a very nice manner. Now, next is like here, you can also ask it to write the songs in different languages, not only English, you can try other languages. Okay, so here is, the rap song on programming. And this is not bad. If you see, this is not bad. I'm a coder, a programmer, a tech savvy guy. I can code in Python, Java, and C++ on the fly. I can build a website, create an app, design a game. I can solve problems, debug code, and play with my brain. You can see, this is something super interesting. This is something super interesting. And yeah, so here is a pseudocode to invert a binary tree. Okay. Now, you'll be amazed that it is able to give answers to the coding questions. The biggest, you know, uh, biggest surprise to me was that when I asked a couple of coding questions and it was able to give answers. All right. You might wonder that is that an end to coding questions? The answer is no. Okay, because in coding questions, usually people have more detailed discussions rather than only the code. All right. So what you see is just miraculous. Okay. So when Alexa and other tools were launched, I was not impressed because when I asked it a slightly difficult question, it could not, it could not give the answer. Okay. But when I used ChatGPT, I was impressed. And I said that, that this is essentially very surprising. I have known the architectures of GPT and other systems for quite some time, but I never expected it to be so good. Okay. The architecture of ChatGPT or anything, this has been there in our courses and for quite some time, for two years probably, like transformer model and other things. But I wasn't I wasn't very confident that this will become this smart. Okay. But what has happened is with a couple of tweaks at GPT and training the same model and scaling to such a large scale has led to this brain. Nobody's coding it up, these answers. These answers, people are not coding up. Okay. These answers, which are so correct, are being automatically done by computer. Now, this is important. This is crazy important. So this is not like if you talk to people at Alexa, you will or Amazon, you'll find that most of those things were hard coded by engineers. Here, this is not hard coded by engineers. Nobody wrote that if somebody asks a question on inverting a binary tree, give this as answer. Now, this is extremely good, and I'm going to walk you through what makes it that's this powerful. What is the what exactly is the science behind it? So I'll start in a very simple manner. First question that I ask is, how does a machine learn? Machine doesn't learn by, true learning is by the way of giving it examples and let it learn, right? Instead of you coding it up, instead of you writing if else conditions that if this is this, then do this, if this is this, then do that. Instead, you say that this is good, this is bad, this is good, this is bad. And then it learns by figuring it out, right? Remember the spam example, like email spam example, whereby we teach machine how to classify an email into spam or not spam. One way is we write the logic saying if the subject is this, then it could be spam. If subject contains these words, then it could be spam. The other way is we convert the email into a bunch of numbers and feed those numbers to our machine learning model and tell machine learning model that these numbers are spam, these are not spam. Now let the machine learning model figure out whether, what does it mean by spam? And that's the heart of machine learning, figuring out the logic from the data. Okay, so I'm going to do very briefly. So I'm going to focus on a technique called a neural network. This technique of making machines learn is very much inspired by animal brain. Okay. And in very simple words, okay, like it's as much inspired by human brain as much as the engine inspired by the human body. Okay. So I hope you got the context. Though it looks like it is inspired by brain, but brain is far more complex, far more versatile, than this model or the neural networks. Okay, neural networks do not learn by themselves. Neural network need supervision. Okay, so what exactly is a neural network? That's what I'll talk about in the beginning. So you have these bunch of knobs. You can think of a big grid of knobs. Okay, big grid of knobs. On one side, you feed the input, and on the other side comes the output. Now, question is, who fine-tunes these knobs, right? How does this knob get fine-tuned, right? So you have a training phase. What you do in the training phase, you say that this is my input and this is my expected output. And then these knobs need to be tweaked in order to match all the inputs and all the outputs, or closely match the expected output with the input. Maybe there are some outliers, we'll basically ignore those. So that's the art, that's a training phase. In the training phase, what we do is we tweak these knobs, okay? We tweak these knobs such that it starts giving outputs which are closer to expected outputs, okay? This is the simplest way you can think of, okay? In case of GPT, there are more than 140 billion knobs. Okay, there are 140 billion knobs in the GPT 3.5 or 3. I'll talk about that in detail. So what you have is that you have these billions of knobs, and you start tweaking it such that the expected output is matching the actual output is matching the expected output. Okay, so this is essentially what it is. Okay, now the question is, how do we cleverly tweak these knobs instead of, if you can think of like a billion knobs, there are a billion knobs and you have to tweak each one of them, and each knob can take, say, more than 1,000 values. So how would you tweak these knobs, right? So if each knob is being tweaked, right? So how many permutations will it take? So each knob can take like 1,000 positions, okay? And for each value of one, there are other values of the other ones. So it'll be like 1,000 to the power a billion, okay? 1,000, because each value could be take 1,000, right? So 1,000 to the power a billion. Those many permutations, which is impossible to try, right? Therefore, there are techniques like a little more greedy techniques, whereby what we do is we slightly tweak it and see if the output is matching with the expected output. And then if it is matching, it is going in the matching direction, then we tweak it a bit more. Otherwise, we tweak in the opposite direction. Okay, just like when you take bath in the morning on a cold day, and you don't know which knob, you don't know which one is hot and which one is cold knob, right? So you slightly tweak it, observe whether it's going to the nicer side. If it's going to the nicer side, you just keep tweaking further. Otherwise, you tweak in the opposite direction. All right, so that's called the backpropagation or gradient descent. Okay, you basically tweak these ones first, then these one first, then these one, then these one. Okay, so that's what you do. So that's called backpropagation, because you first update these, then these, then these, and then these, right? So essentially, that's the model. Or you can think of it like we start from the right-hand side, and we basically do these, tweak these all together because they are not interdependent. These are interdependent. Okay, these are interdependent. The next layer is independent. So we feed the input, it gets multiplied by some value here, and then there is some kind of a cutoff here, and then there and further. So that's essentially the standards of neural network. The most important part to notice is that there is input and expected output. Once the training phase is done, you have the inference phase. In the inference phase, you do not tweak this model. You do not tweak this model. You just use the whatever knob positions are there, you mark those positions after the training, you mark those positions, save it in a file, put it on the server, and then launch it there. So these knob positions are what we call a neural network model. Okay, and when an unseen input comes, you feed it to this model, or you can say the bunch of knobs, and it'll give you the output. Okay, so this is training phase where you have input and outputs, and you're figuring out the model, the reason you see the question mark here. And in case of inference phase, you have, okay. All right. In case of inference phase, you have what you do is you have frozen the model, and for an unseen input, that the input that this has not seen before, it would be able to give the output. All right, or for any input for that matter. All right, all right. Now let me just give you slight bit more details into neural network. Okay, so there is an input layer. These lines that you see here, the connecting lines, these lines are what I'm terming as knobs. These knobs here are basically these connecting lines or connections, okay? And basically these are neurons and these are synaptic nerves, and which are connecting to the next one. And when we say training, we are essentially making this connection either stronger or making it lighter. So when I say knobs, knobs are these connections, okay? So don't get confused with the circles, right? These circles represent the strength of these connections, not the neuron, these connections, okay? So you have input and the output. The question is, how do we, let's say, who decides the output layer? Output layer is decided, the number of neurons is up to us because this is a function of whatever problem statement is. Imagine that given a photo, we have to predict whether it's a male or a female. Then a single neuron is sufficient. Or, right, if you have 3 classes, usually you will put 3 neurons in the output. And the input is a function of what kind of data do you have. If you have an image, you will have a rectangular public convolution here. Or if you have like 5,000 features, you will have this, right? So neural network, what you see here is takes numbers as the input, gives numbers as the output, okay? Now the question is, what do we do in case of male, female? We output the probability of each category. So for classification, we output the probabilities here. And for other things, we output the, let's say, 1,000 categories, there'll be 1,000 neurons here, and we'll output the probability of each one. Okay, so that's the neural network, and it can be used for regression and classification. And it's essentially a bunch of knobs we are tweaking in order to achieve what we are looking for. Okay. Now, a question that people ask is, like, I'm going straight towards my main topic. Okay. Question is, this neural network that you see, it can do classification, it can do regression, but how will it produce a word? How will it produce a word? That's a question. That's a fairly hard question to answer. Okay, so predicting a word, okay, predicting a word is essentially a classification problem. Okay, meaning given a dictionary of 50,000 words, okay, you have to give 50,000 probabilities at the output. Okay, imagine that the dictionary size is 50,000. Okay, so the neural network will output 50,000 probabilities or 50,000 decimal numbers. Okay, and whichever is the highest, we pick that word. So that's how the model outputs the word. Okay, what you saw in case of ChatGPT, when it was giving the word output, it was the output coming from the neuron. First, the neural network was giving list of probabilities for all the words in the dictionary, and then we were picking the one that was highest, and then we were picking the corresponding word from the dictionary, and was giving you that one. Okay, so that's what was happening in case of ChatGPT. So model outputs the word is model outputting the word, model outputting a word is essentially classification problem with 50,000 classes. Okay. So this is what I talked about. So so the way we usually handle this is that imagine that your input is the cat and the dog, right? So what it does is it'll convert each of them into tokens. Tokens are like state in the dictionary. We'll give them number from like some like ID from the dictionary, and this becomes a class. Okay, so we are essentially inputting the one hard-coded vector. What do you do in case of when you are feeding categorical variable into a machine learning model? You convert it into a one-hot encoding, and that's what you do, right? It's like a big sparse matrix. It's saying like it has the features are each of these words, and there's an ID, and that's how it is. Okay, so that's how we feed a single word, and this is how we handle the output of it. Now, question is, so we talked about how to take a word as input and give word as output. Okay, we talked about taking word as input and taking word as output. Now, question is, how would a system take a sentence as input? Or how would a system maintain the context? Imagine that, okay, so there are multiple things to it, okay? Now, there are multiple parts to this question. One is, how would a model take a sentence as input? And second is, how would a model produce a sentence as output? I'm going to talk about both the things. Now, if we are just, feeding one word at a time, and there's no context, like this cat is good, right? First, we fed one of the rows of the data is this. And the second word we are feeding as is, right? Now, the model can't do anything just based on one word. It can't predict anything, okay? You have to give it context. You have to give it like a sequence of words. So to handle this problem of sequence, recurrent neural network were invented, okay? Recurrent neural network were invented so that what used to happen is you have a neuron, you feed one value, and then it gives the output, and then whatever is this output, you again feed it further with the next step. So previous steps output, and this one gets fed next time, and then you get more output, and then again you feed, and so on. So what you see here on the right side, this is like unrolled neural network in the time. So at the first step, it's the same neural network, okay? So you feed, let's say at 0, right? This, you get some outcome, then you feed this one, you feed this one again to the next, at the next step, okay? And so on. So, and then we feed again and we feed again. So here, what you see is essentially, all right, what you see here is that essentially the context of this one, this previous time is coming here, and then here, and here, and here, like this, right? You can see the arrow. So it's essentially time unrolled, okay? So using recurrent network, we solved the problem. But the problem was, when we trained this neural network, right, there is something called backpropagation through time. That's an algorithm. There's a little variation of what I just explained to you, backpropagation. And there, what was happening is, in the recurrent neural networks, a big trouble was trying to train the model. The moment the sequence length, like the moment the sentence become bigger, the model was losing what the context of the whole sentence was. So let me first, talk about the recurrent neural network a bit more. So there was lots of inventions, a lot of work done on recurrent neural networks. One of the models that people designed was encoder and decoder model. Okay, you feed an input, encoder encodes to some bunch of numbers, and those bunch of numbers get translated to an output. Remember those debates about using Sanskrit as one of the intermediate languages for English translation? That idea basically evolved into this kind of thing. So imagine that you are writing a translator, you are writing a model that can translate to French, from French to English, English to French, English to Hindi, Hindi to English, and so on, right? So a smarter thing would be that we take the one language, feed it to an encoder, it'll generate the meaning of it in the midway, and then we feed it to the decoder, and the decoder will translate to the another language, right? Let's say, I like maths. Okay, I like maths, for example, I'm feeding it here, and then we are encoding it. And using this encoder, we are translating to an intermediate language. And then from that one, we are translating back to, let's say, Hindi, saying, Mujhe garit pasand hai, right? Now, the question was that long debate happened in past. Some people said that use more structured language like Sanskrit, or some people said that why don't we create a new programming language to represent the middle part, and so on. But what was successful in this case was that this part needs to be bunch of numbers. This needs to be bunch of numbers, essentially a vector of decimal numbers. So the meaning of words is bunch of numbers, not a single number. So similarly, when people ask me, like, what's the meaning of life and everything, I'll say it would be a vector. Okay, so this is a vector. A vector is nothing but bunch of numbers. All right. Next is, so that's what I just described. Now, here is another detailed picture of encoder, decoder, right? So this is the part where there is an encoder and there is a part called decoder. And it's a pretty simple diagram. Don't turn off. This is essentially pretty simple. I'll explain to you. Imagine that here we are feeding. This is a translator. We are trying to translate. We are trying to translate from English to French. Okay. We are trying to translate from English to French. This is from their standard paper of NMT. We call it Neural Machine Translation of Google. It was published by Google. Now, so what I'm trying to do here is, just give me a moment. All right, just give me a moment. Okay. I'm not able to see the chats. All right, I'll take the questions probably at a later point of time. Okay. And yeah, I'll talk about these questions. My team is picking the questions and giving it to me. So I'll be taking these questions towards the end. Okay, because there are lots of things. I'm trying to compress a whole thick book of neural networks, or right. If you see last year in 2021, the number of published papers in the neural networks is just too many, right? So if you just pick all the papers on which ChatGPT is based, it'll be more than 1,000 papers. If not 1,000, probably 500 minimum. Okay. So whatever I'm trying to compress is into this small discussion is essentially very impossible. So I'm going to just focus on what's important and what's not. Okay. So now I was just describing you this encoder decoder, or we call it transformer model. Okay. You must have heard about transformer model, but let me just simplify it for you. This is a transformer model where there is an encoder, there is a decoder. We feed English language to this, and we get the probabilities of each word And then essentially it outputs one word at a time, right? It outputs one word at a time, and then we basically feed that word again back here. It gives the next word, and then we feed it again, and then we get the next word, and so on, right? And that's what you see over here. And this is a very important aspect of this diagram. Even though we are not using the underlying machinery as such, but this machinery we are using in case of ChatGPT. Okay, so what's happening here is we fed I drink milk in a reverse way, turn them into IDs, and each ID becomes like a one feature vector. This also becomes one feature vector. And we feed that. First, we feed this one, then this one, and this one, right? So we feed these three words one at a time. Then once it is done, till that point of time, whatever output is the neural network giving, we are ignoring it. So we are saying that listen to me till I finish my sentence. And then once the sentence is finished, then what we are saying, go, right? Go is important here. We represent in case of Instruct GPT as $1, and it start giving the outcome. So it gives us day. Then this is the actual translation. Please notice, this is the actual translation. This is the our sentence. This is the actual translation. And here it's producing it. So you might wonder that one, so this one would expect two sets of input, right? One is the actual sentence. The other is the whatever it's giving the output, right? You might wonder, like, I'm asking it to translate English to French, and it's asking French as an input. What kind of crazy system is this, right? No, it's not like that. So when we say go, it says a word. When we are running this in production, then we feed this J back here, and then it gives the next word. Then we take this and feed it here. Then we take this, feed it back, and so on. So we keep on doing that in the production time. Notice that in the beginning, it doesn't feed anything. So when we are, first we feed I drink milk, and then we say go, and then it gives the output, and then we feed it back, then we feed it back, then we feed it back, then we feed it back. At the training time, since we have original sentence, we feed that original sentence as well here. All right, I hope I made it clear. So essentially, first step in this case, everywhere is embedding lookup. What does embedding lookup means? Usually convert the word into some form of number. Usually what people did earlier was prepare the word representation using another model, which will convert each word into more meaningful numbers. Okay, so that's another debate for another time, but we will talk about how ChatGPT avoided this part and how did they do a better job. In case of the NMT, the neural machine translation, this was done through another machine learning model, which translated every word into a vector such that the words which are same in the meaning, their vectors have a smaller distance. They're closer to each other. Like, for example, men and women, like distance between man and woman and distance between man and say table will be different. So distance between man and woman will be smaller as compared to distance between man and the table. So that it figured out by studying those kind of, previously what people used to do is they'll crawl the internet, figure out the meaning of words based on the context, and that's the extension into the ChatGPT as well. Okay, so this was encoder decoder model. So this encoder decoder model was based on the recurrent neural network, where you have a neuron and you feed back again and again, and so on. And then there was a big shift, or you can say invention, called transformer. Instead of feeding over and over into the same neuron, they came up with an idea called attention. Okay, idea called attention. The idea of attention is this: you have one set of argument, one set of context, you have some sort of neurons here connecting to this and so on, and you get the summary. So essentially, it is more like taking this, multiply with this, and we get the outcome. So that was essentially the role of attention was. So attention, if you search for a paper called Attention is All You Need, that's basically a wonderful, wonderful idea. You can just take a look at that paper called Attention is All You Need. And that led to increased performance of the NMT, the neural machine translator. Okay, so instead of using instead of using the LSTM or RNN, recurrent neural network, we started using something called attention. Okay. And as of now, transformer essentially means attention. Okay. So usually transformer, what it did was one of the very clever idea, right? One of the clever idea here was right here, I drink milk. Okay. Now, the problem here is that when I say I drink milk, it is assumed that the milk, right? The definition of milk is dependent on I because I'm feeding I first and then drink, then milk. Okay. Please notice the reversed order. So I'm feeding I first, then drink, and then milk. Okay. It is assumed that I is the most important word, but that may not be true all the time. Okay. So the influence, as you move ahead, by the time you reach milk, the influence of I has reduced and so on. So it is assumed here is that the word that is appearing just before the current word carries more meaning and so on, right? And that's exactly why we have reversed this order. So we feed milk. Sorry, yeah. Again, let me put it again. So we feed milk first, then drink, then I. Why we are feeding this I last? Because I carries most influence, because just after I, we ask it to produce something. Therefore, I is the most significant. Now, this significance is something very subjective. It depends on language, it depends on sentence, and so on. So it's not always that the first word in every sentence has to be most important. Okay. Therefore, what newer model came up with the idea of something called positional embedding. Okay, so one is they replaced the LSTM with something called attention or multi-head attention, and then there were variations of self-attention. So they basically focused a lot on right. If you take a look at the transformer paper, you'll find that they have come up with applying attention everywhere. Okay, attention is this wonderful paper. In case you want to go ahead, okay, if you want to go ahead with, let's say, the search for attention is all you need. Okay. So this paper by Vaswani and company, this is one of the things that deals and details around what exactly is like the attention. So attention was a replacement for recurrent in many cases, and it worked out pretty well. Okay, so you can take a look at this paper if you are more interested in. Okay, let me just put it on the chat. So you can see here, right? This here he talks about the architecture of the NMT here, right? So you can see that the inputs and outputs remain exactly the way we talked about. Then there is embedding, and then there's something called positional embedding. Okay, so this is encoder, this is decoder. Encoder learns from the input along with the positions of the words. Okay, and then here is the meaning that is coming out. Then there is an output which is shifted right, meaning we're saying go, and then it produces one word, and then we feed that word back again. It gives the next word, and then we feed it again, the next word, and then it gives again. So what's happening here is in this architecture is basically this is a replacement of this model. Okay, so instead of using the RNN, people started using attention. Okay, now because there were troubles with RNN because you could not train it for long sentences. It did not understand, like in case the most important word was the last one in the sentence, it couldn't figure out the meaning of the first word. So those were the problems with the RNN-based systems. Okay, so moving on. Now the same thing, it became like multi-head attention, self-attention, and so on. Okay, now, so I talked briefly about positional encoding. So positional encoding is essentially converting the positions into some form of numbers. It does it based on some calculation. Specifically, it takes sine and cos of those positions and then comes up with them. So this is the transformer architecture that I talked about. Again, I can show you. This architecture is not exactly what is being used in GPT. Okay, this architecture is not what is being used in GPT. This part, the right-hand side part, is the only part that is being used by GPT. And instead of taking input from here, there is a self-attention which gets connected here. Essentially, the previous sentence or previous word gets fed again and again. So here, what you see is there is an input. It gets converted into input embedding, meaning the IDs. And then there is a positional encoding based on the position of the words. It basically puts that vector here that gets added to each of the words. And then what you have is some basically neural network that converts it into a bunch of numbers. And then you have the output where initially we don't feed anything. It produces a word. Then we feed that word, we get another one. Okay. So that's what is happening. Like, for example, in case of GPT, what they did was they picked this part. We call it transformer decoder. This part is encoder, this part is decoder. Okay, so transformer decoder, you can just think of this again. Instead of you getting confused, you think of it as bunch of knobs, like a billion knobs in this box, and that does the black magic. Okay, so what it does is we feed it like robot must obey, and it should predict the next word. Okay, it should predict the next word. What they did in GPT is that they downloaded the entire of the internet, as well as like they downloaded the data from many places. And then from that data, what they did was they converted that data into something that can be fed to the neural network, right? So this is essentially mostly unsupervised learning. I'll talk about in more details. Okay. One of the things that I talked about is something like a translator. And I want to talk about the beam search briefly because it's needed here, right? So for example, since the model is going to spit out one word at a time, right? How do you predict the next word? So what you do is imagine that we said something like this, right? And it says two words like, how are you? Two sentences is produced. One is, how are you? And how will you, right? So which one will you pick? This is the correct one, but can we make it better? Okay. Now, since we said that the model produces one word at a time, right? So you have first word is how, second word is what, third word is you, right? Now, we're going to feed these words again back into the model. Imagine that it has produced, say, 10,000 such words. Okay, 10,000 such words, because dictionary is 10,000 word long. So this model is going to give the probabilities of all the 10,000 words, or 50,000 is the correct size of the dictionary. So imagine that this model is giving the 50,000 probabilities of all the words. So you got these words. So usually what we do is instead of trying only for the best word, we basically pick the top 3, or we call that beam width. So that's a configurable thing. So let's say we pick the top 3 word, and then again, feed these words to the model and say that, tell me the next word. After how, what should I say? Then after what should I say? After you, what should I say? And the model says that after how, you should say will, or are, or do, and so on. So this way, model is again predicting 10,000 output. So we basically pick top 3, again top 3, and top 3. Now, when you have the next level, again, from all of these across, we pick only top 3. And then again, we keep on doing this. So if you see, it's more like, you know, there's a game going on and the model is learning to pick and choose. So essentially, this is, again, like reinforcement learning. So you will notice that ChatGPT basically learns from this. They train a separate model to pick and choose the things and fine tune that selection of the last word. I'll talk about that very soon. Okay, so this is essentially beam search. I hope it is clear to all. So you basically ask the model to give me the next word, and when the model gives you the next word, you pick only the top 3, and then you feed all those top 3 words into the model again. You get again 30,000, not 30,000, 50,000 times 3. Okay, you pick the most popular words here, and then most popular this, and then you pick again top 3 and so on. Now, when you're picking, what you do is you multiply this probability with the next probability and pick the best ones from there. Okay, so that way you essentially get the perfect sentence. So that's what is happening in case of ChatGPT, that when it produces a next word, right, when it is producing a sentence or it is producing a message to you, right, what it's doing is at every step, it is just producing one word, right? Now, internally, what it is doing is that basically producing the probability of 50,000 words, or you can say 50,000 words, and you're picking the one with the highest probability. And then you're picking that, because probability is what it is predicting. Okay. Now then once you have the next word, then it again feeds that previous word and then asks transformer again, hey, give me the next word. And that's what keep on going. Okay. So I'll talk about this in more details, right? All right. One of the most important inventions for which there were the Turing Award was given, and the Turing Award was given for this invention, the transfer learning, or being able to transfer the learning, right? And this changes a lot of things. For example, now instead of only the code being the copyrighted, it is the model that is copyrighted. So we all know that GPT was based on other models, while ChatGPT is essentially based on GPT. So we all know, right? So the main idea that actually is a big breakthrough. The main idea is, how do you train a machine with minimal supervision? Right? We saw in neural network, though it requires input and expected output, input and expected output. Now the question is, we can't really label everything. We can't always keep saying that this is the question, this is the answer, this is the question, this is the answer, this is the question, this is the answer. No, we can't do that, right? We can't do that. Though there were in past the people like the auto reply, yes, from Gmail. The Gmail auto reply was created based on the Linux forum, where there were questions and answers, and they trained the neural network. But it is not as powerful because it was just basing there. They did invention in terms of transfer learning, But the more important part is to understand how do you train a machine without supervision, right? So one of the very clever aspects of training neural networks is, yeah. So other challenge is that you have like a million different kind of tasks. One of the tasks is about generating code, other is asking whether this code is correct, other is, there are thousands of kind of language tasks or tasks for, everything, not thousands, millions. Now you can't gather the labels for all kinds of tasks, and then you can retrain the model from the beginning, and so it's like impossible, right? Therefore the minimal supervision is needed. Okay, so one of the key ideas that came is that what you do is you download the internet. So the core idea is that meaning of word, the way human learns the meaning of word, can we do the same thing in case of neural networks, right? How does a human learn the meaning of a word, right? So if a word is existing in a context, we kind of associate and figure out the meaning. Remember you reading novels? Did you really, let's say those who have come from, let's say, Hindi and are learning the novels in English, do you really learn the meaning of words from the dictionary? No, right? Most of the meaning of words you have learned by reading, right? The moment you see a same word in the same context, you can kind of relate to it. And that's exactly what has been done in case of the embeddings or pre-training of GPT. So pre-training, what we do is we take the internet data, we take the sentence, we say that, okay, complete this sentence, tell me the next word to speak. Okay, so imagine that there is a website and the website says, this is a cow, right? This is a cow. So what we feed to the neural network, we say, this is a, and then we say dollar. And now we ask it that produce cow, produce the maximum probability for cow. Okay. So that's what we ask the neural network to do it over and over. Okay. So now you see that suddenly we have created the label data. This is our input, and expected output is cow, right? So based on the internet data, we created the input and output, and with which we trained the neural network. Now, the amazing part of this was that retraining this model slightly with different objectives was not difficult. It was not difficult. Now, the other important part you should know is that what we usually do is, imagine that you have a model, right? This is my model, and we are feeding it one task A, right? There is an input and there is an expected output. If this model was trained on same kind of input, okay, same kind of input, we can use this model even if there is a different expectation. So what you usually do is, imagine that this is your model. Okay, it takes, let's say, English sentence, right? English sentence. It produces the next word. Okay, it produces the next word. All right. Now what we want to do is we wanted to say, instead of producing the next word as is, we wanted to say produce sentiment. For example, is it positive or negative? Okay, we wanted to produce the sentiment. So, and this model is really good at producing the next word. Okay, this model, these bunch of knobs, billions of knobs, take the English sentence and produce the next word. Okay, so what we do is we just take these bunch of knobs as is, we put one more set of knobs here, Okay, we put one more set of knobs. Okay, and then that produces the sentiment of it. So the amazing part about the neural networks is that as long as the input is similar, okay, we can reuse the model, okay, by just adding one more layer or deleting some layer and adding one more layer here. So like that, and retraining a little bit on the newer data. Okay, so that's a core idea that has worked with ChatGPT. Okay, that's a core idea that has worked with ChatGPT. So they basically trained the model on unsupervised way first, and then they started retraining it. Okay, so we reuse the model from previous task, initialize the model with pre-trained weights, and then fine-tune the model for the new tasks. Okay, so essentially that's the main idea. Okay, so an a natural language processing model developed by now let's get back to GPT. GPT is essentially generative pre-trained transformer. This transformer is not like a complete transformer. It's only the decoder part of the transformer. And it's pre-trained. Why we call it pre-trained? Because it is trained using humongous data set from the internet. It's generative because it produces a sentence. That's why we call it generative pre-trained transformer. Okay, so it's essentially an NLP model developed by OpenAI, and we utilize the transformer decoder model, only the decoder part of it, and the GPT is pre-trained on large data sets. Okay, it is trained on large data sets. So you can see that that these are the data sets with these many entries. Common crawl is essentially from the internet and so on. Okay, so GPT architecture consists of series of layers, including input layer. Then there are many transformer blocks like bunch of knobs, and then there's an output layer. So this is input, output, and bunch of knobs. That's how you can always think of a neural network. The model can use this probability distribution to generate text by sampling from it. Okay, so from my humongous data set, it can just pick up those. Okay, now, all right. All right. So the way it happens is that we basically feed it something, it gives us word, then we feed it again, it gives us next word, then we give it again, and it gives us next word, and that's what is happening here. This contains all the magic of attention and, multi-head attention and self-attention and so on. Okay. So again, let's now talk about the true architecture from the GPT itself. So GPT is essentially the transformer architecture. These are a bunch of knobs. We are feeding the text, okay, and we are getting the prediction or text classification. Now, okay. All right. Now, this is something that you should pay attention to. I'll go back to that one again here, okay, for the formula. Okay. Now, what they did was they used the same model all across, right? So for a classification of tasks, like if you are classifying a task into, let's say, toxic, non-toxic, what did we do? One token we added was start, and then we added the text, and then another token we added was extract. So these are the bunch of tokens. This is the actual text for which we are trying to classify. We are feeding that to transformer. This is the model, the main model that is being trained, and then we get this, right? Once we have trained this model on the internet data, okay, by giving this is a cow, this is a cat, like the entire data set from the internet, or this followed by question mark, and then so on. So we are basically asking the transformer to predict what is the next word. So we are trying to just tweak those knobs in this case we are basically the unsupervised part. What we're doing is we are trying to tweak these knobs such that it produces the next word. And once we are done with that, we are fine-tuning that model. How are we fine-tuning? The input shall remain in the same format. There has to be start, extract. Similarly, if you're talking about entailment is basically where you have a sentence, and you have a hypothesis, and you have to either come with the hypothesis, or you have to essentially say whether the hypothesis is true or not. So you feed the premise and the hypothesis as a transformer, and then you add one more layer here, and it gives the result. Similarly, a couple of basically weights here. And this is also being trained, this is also being trained, this is also being like that. And this anyway is being fine-tuned. So similarity, if you want to use, so you basically convert this sentence into text 1, text 2. If you're trying to figure out, let's say this text 1 is similar to text 2, or text 2 is similar to text 1. So you can utilize the same model that you trained in an unsupervised fashion for all kinds of tasks. And that's wonderful GPT. Okay, this is GPT. Okay, and you can utilize it for all kinds of tasks. And let me just, those who are interested in a bit of maths, okay, so when we are training in an unsupervised fashion, the GPT, we are feeding this data. These are tokens from the internet. We are predicting the probability of the next token given first K tokens. So we are feeding K tokens and asking it to predict the next token. And we are doing it for all the sentence, right? So when I say this is a cow, this is a, right? So we are feeding this is a, and we are asking it to produce cow. And this theta means the weights. And this is basically our loss function. So as part of the entire maths, what we are saying is predict the, like, maximize the chance, maximize the probability of predicting the next word in a big sentence, having, like, we are going to feed keywords at a time, previous keywords, based on previous keyword, predict the next word, and that's what we are doing here. Okay, so this loss function, this loss represents how much error it is making, and we want to the likelihood, not the loss. This is likelihood, so we want to maximize this. And yeah, now here there is one more thing. So there are two things we are inputting to it. One is u, and the basically we are also, this is the context vector. This is the context vector that we are feeding to it. And then this is the embedding vector. This is the words that we are feeding. And then we are basically feeding something called position vector as well. Okay. Now we take the same model and start fine-tuning on a supervised task. Like, this is my label and these are my words that we are speaking. So this is the context. So our model, same model, needs to come up with the correct label. It needs to come up with the correct label, and that's our loss function. So here we are trying to basically do the supervised prediction, while here we were doing the unsupervised. Okay. Now, additionally, what they find was that making both of them together, like this plus this, okay, both of them together, this is some weightage they put around, say, 0.5. So when they put this weightage, that it gave a better result. Okay. And then you can utilize the GPT for all kinds of, context vectors, and you can actually fine tune it that way. Okay. So GPT can be fine-tuned for specific tasks such as translation, summarization, or question answering by adding a specific layer, one more layer at the end, and that's about it. Okay, depending upon the task. Now, one of the surprising things about GPT was its size. Okay, the size of the GPT is 180 billion parameters, which is humongous, and which is way magnitudes larger than any of the previous models, right? You can see it is 10 times bigger than this one. Okay. All right. I'll quickly go over one more thing that people have is like, what exactly is reinforcement learning? Reinforcement learning is, let's say, the way you play a game, the way human interact with the environment. That's exactly the reinforcement learning. There is an environment and there is an agent. Agent need to come up with a model or a policy such that it can take action and maximize its long-term rewards. Okay, so essentially that's what is the one. Now, one of the things ChatGPT did was using reinforcement learning. So what reinforcement learning, what it did was they created another model, and the environment is the like responses that GPT is giving, and then this is learning to nudge the GPT. So there is a separate model which essentially kind of a reinforcement model that improves the GPT. So I'll talk about this. All right. So chat GPT, all right. So essentially, if you go back here, so GPT is mostly trained using unsupervised learning from the data. We sometimes call it self-supervised, like that. And it's humongous model. And GPT brought a lot of changes the way people have done things. People created many things using GPT, but GPT was not very great, and sometimes it did messy things. It basically was a probabilistic guess of next word, right? It didn't really had a very good meaning of the context sometimes. So sometimes GPT also lied, right? So to avoid that, what researchers did was they took GPT and then retrain it on human curated data set. Okay, on human curated data set, they basically used reinforcement learning to during this fine tuning. That's where the reinforcement learning was used. Trainers then, what people did was what they got the access to the answer, all the possible answers that model could give, and then trainers also rated those answers and then again fine-tuned the model using that. So first part was like, these are the three phases of ChatGPT. A prompt is sampled from our prompt data set. Okay, a labeler demonstrates the desired output behavior, and this data is used to fine-tune the GPT-3 with supervised learning. Okay, so you have a bunch of prompts, you ask the answer to a human labeler that, okay, what is your answer? And the same thing is compared with the output of the model. Okay, and you can say fine-tune, the model is fine-tuned if it's not giving those answers. Second was collect comparison data. A prompt and the several model outputs are sampled. Okay, the labeler ranks the outputs from the best to worst. Okay, so there's a prompt, and then there are many answers that were gathered, and then labelers, human labelers, were asked to rate which one is good. Now, this data is used to train the reward model. Now, you may ask that what was the use of unsupervised learning when we had the human labelers, right? The answer is that these were like 40 people, okay? They can't really produce, internet size of knowledge. So the knowledge of GPT is done by self-study on the internet. Self-study as in trying to guess the next word and learning from that. And based on the self-study, we built the GPT-3. And from that GPT-3, we fine-tuned, number one, the answers of the model based on the human one, and then the probabilities of the answer by the human intervention. This is where the reinforcement learning is being used, right? Because the reward model is used here so that So that at every point, remember the beam search where every word is being outputted. There, the reward model is nudging the telling that the reward model is actually producing the how good is this word? Okay, how good is this word? And basically that's being used as a step in fine tuning the ChatGPT. Okay, the step 3 is optimize the policy against the reward model using reinforcement learning. All right. So this is again taking the reinforcement learning to a next step using the BPO, and that's about it. Okay. So right, that's pretty much I wanted to talk about. I wanted to talk about the limitations of ChatGPT. One is wrong answers, because ChatGPT is a language model. It might provide wrong answers. Okay. Bias issues. ChatGPT can generate discriminatory results. Okay. And so on. One of the limitations of ChatGPT is that it is monopolized by a single company. Okay. They spent a lot of hardware, a lot of time, and they basically came up with the model, and they have not made it public. Okay, though they have published a paper on Instruct GPT, which is essentially the mother of ChatGPT. Now, the Instruct GPT paper is published and is open and accessible to everybody. They have not made the model public for public consumption. Neither GPT-3 nor this. They have provided a website. They have provided an API to use. And I just hope that other people would be able to, come up with the similar model and make it public. Usually in the case of machine learning, people not only publish the papers or publish their research on their blogs or something, they also make the models public, right? If you take a look at, say YOLO, like when I say model public, as in something that you can load and start using, okay? Instead of depending on somebody's website, if tomorrow they start charging for every API call, you would not be able to use it. Right. So you have these models. Essentially, this is those bunch of knobs that I talked about. You can just download it and use it in your software. Okay. And you can host it. And similarly, you have lots of such, models available, so that you can also take it and fine tune it at your own one. Right now, the model of ChatGPT is basically very kind of, it's OpenAI's property. It's not available for people to retrain. It's not available for people to reuse. You can only give it an input and it gives output via their own servers. So I just hope that as more researchers join and more people become more educated, they would be able to dare and build GPT model, their own GPT model that they can retrain using similar techniques like ChatGPT. Okay, because there are so many use cases, there are so many utilities. You all must have envisioned about it. It has way bigger understanding than I do, and it has essentially great, great use cases for people, and that's why I believe that it needs to be made open and public. Right now, it is essentially a property of OpenAI, but their research itself is dependent on so many other papers. So thanks to them that they made the paper public, but they have not made the model downloadable or public so that you can use it or retrain it. It's only, you apply to them and then they might choose, select or unselect you. And that too, there are lots of strings attached. So I just hope that other people come up with similar quality model and make it public and make it available for everybody and make the world a better place. All right, so that's about what my so far the monologue was. I will pick the questions now and we'll try to answer those. My team can help me pick the questions from the chat. Okay. Our question is, very excited to know if ChatGPT can actually be customized to extract data from CRM systems and answer specific customer queries. Wow. Yes, that's a wonderful question. Okay, wonderful question. And I would, yes, it is very much possible to do that. Imagine that you take the ChatGPT model and you feed it a bunch of like questions, and it essentially creates a model for your website, or you can just feed the website to it and it crawls through the website and figures out what is it that you're selling, and you get the sales agent. And it basically, essentially, it would be a breakthrough in the case of, answering people's queries, right? And the great part is that lots of people essentially, specifically, if you look at the sales agent, right, the people who work in sales at companies, they end up, spending lots of time on, basic questions, while they should be spending more time on quality questions. And so probably such kind of model also give a nudge to the sales team that, hey, now is the time to intervene. Okay, so all right, that was a wonderful question. Now the second question is, okay, I think a better thing is if I just paste these questions one at a time onto a notebook or something. All right. Okay. All right. Let me just clean up my desktop so that I can share the screen. Okay. All right, there we go. So yeah, I'll just pick one question at a time. So I've answered this question, right, here. Okay, this question is by Harish. It's a great question, and I would love to see that. And that's the first, use case that seems like a real value to me as well. Okay. All right. Now, a question is, let me say, yeah. Okay, so ChatGPT and DALL-E 2 and stuff, when adopted by people, will need tremendous data processing resources. Will there be a great demand for data centers? How much capacity is needed according to you? Okay, very good question. Very good question. Okay, so if you take a look at, say, ChatGPT model, it's around 900 GB, right? That's the size of the model. Okay, so in order to use inference on such kind of model, you would require 1 TB of RAM or something like that. Okay, or you need some extreme clever techniques. Okay, so if you are just using their API, okay, then you would not, right? If you're just using their API, not much of hardware. Okay, if you are training or retraining such model, then you need GPU, and for running the inference, okay, you will need multiple things. Okay, you will need for running the inference, you will probably need clever way to run it on multiple machines and keep it low footprint and trigger it when there's a traffic and there's no traffic. So for running the inference, again, you need lots of knowledge of DevOps, machine learning. You will, right? So with respect to hardware, you will need decent hardware, right? But if you're using right, good, now for retraining and training, you need GPUs. Now, everywhere in all the three, what you actually need and what is the biggest cost is training the people. People who deal with future models, they should know machine learning, DevOps, and system design. Okay, because when you have, or probably you also need like data engineers if you have humongous data, and then you're right. So the skills other than the hardware, the biggest challenge or biggest cost that you'll face is with respect to the engineers. And yes, right now the ChatGPT can't code that much that it can replace engineers. It can probably give you the prototype of a website, but not, if there's a production and there are like 50 files and you have to figure out which one is causing error, that kind of thing it can't give. Okay. Okay. Just to be clear, I'm not funded by OpenAI. I'm an independent person, okay, from CloudxLab. Okay. Now, point from is have been using ChatGPT a lot. I see it a great wrapper around Google search. You have you can give conditions such as word limit and syllable count. The output lovely. However, I asked the question, what is the impact of Ukraine war on the climate change? The answer was banal, and that was expected, right? That is expected, correct. So that's yeah. So that's basically yeah. If you already know what's a Ukraine war and the climate change and other things, right? But if you can ask like Ukraine war on economy for a person who has no clue what is the Ukraine war and what is the economy, probably for them, the answer could be less banal and more meaningful. So it looks like a Google search right now because we are used to using Google search. We think that we basically give it a keywords, bunch of keywords, and it gives an answer. Here, it is very much possible to actually ask a meaningful question. For example, I asked a very different question. I asked it like, I'm using a heart rate sensor to build a lie detector. And the heart rate sensor is giving me the color values at different times. How do I convert these color values into beats per minute? And the answer it gave was very interesting. It gave me the formula, though sometimes the formulas are wrong, but it gave a good formula in the sense that it told me that why don't you just count the peaks of the plot of the data in a minute, and that'll give you the beats per minute. So at number of things, it is way smarter than Google search. Okay. And I would not use Google search for large questions. I will use Google search for basic, keyword kind of results, but without, I would not search if it's not pattern matching somewhere. Okay. Though they're trying and they have a better model in place, but they're probably are yet to make it public. They are very much afraid of Google is get lots of criticism very quickly. That's why Google avoids making lots of things public. Okay, so that's my hypothesis. Okay. Our question is, can you explain more on the nodes in the input layer? Input layers are essentially function of what kind of data do you have? Right? So essentially, like in this case, since we are feeding, say, let's say we are feeding 1,000 words, and the dictionary size is this. So the input size is 50 million values. Okay, that's one row. Okay, so if this is 50,000 is the dictionary size, this is dictionary size, and this 1,000 is like 1,000 words we can feed, and so it's essentially 50 million values. Okay, I mean approximately, not exactly, approximately. Okay, each word is represented by 50,000 numbers. Okay, one word is represented by 50,000 numbers, and therefore it's like that. All right. Of course, it's a sparse vector. It's not like a dense one. Only one value out of 50,000 will be 1, rest will be 0. Okay. All right. I hope that answers your question. A question is, does it replace Docker? Answer is no, it's not Docker, but you will have to utilize in any of the machine learning systems, or any of the system design, system engineering systems in order to launch it. Okay, Docker, what exactly is a Docker? Docker is a way to launch a program in an isolation so that it doesn't interact with the other one, or it doesn't spoil other processes. So you can launch it very instantaneously, and you can launch thousands of such systems parallelly on your cluster. So Docker provides isolation. Okay, so it's a different thing. Question from Abhinand is that what format of data are fed to the nodes? Can you please explain more on the nodes? I hope I was able to answer this question already. All right. A question from Kalyan Raman is, does ChatGPT use embedding? Okay. Good question. Good question. The question is, does ChatGPT use embedding? No. Actually, the ChatGPT uses GPT, which basically is learned embedding or learned model on a larger scale. Okay, the embedding that it was using in the diagram is essentially sometimes just IDs of words represented as a sparse vector. That is what it is. While ChatGPT uses GPT-3, which is the model trained on the internet scale. How can I run my own ChatGPT? That's a hard thing. I would love to do it. That's a question by Soren, that how can I run my own ChatGPT? Okay. And I would also love to do it. Okay. Okay. So the thing is that they have not given the model in public. They have not made the GPT-3 model public. So we can't really create our own ChatGPT out of it. Okay. All right. So what kind of data have been fed into transformer decoder for GPT? Very good question. So this one I have outlined it. I'm hoping that this was answered already. Okay. Okay. And how GPT able to write code? Yeah. Question is, how has GPT been able to write code? Okay, so the way it has written the code is it has gone through the internet, figured out the context of every token being generated, and like the entire of the internet it has gone through. So it understands a bit of code, it understands what next token should be, and so on. So the way it is writing the language, similar to that, it is writing the code. One of the question is, so GPT, as mentioned earlier, natural language processing, I believe the real game is how is it able to produce the output we desire? Correct, correct. So it basically, it's able to understand the context properly. It has an understanding of words, the meaning of them, and the meaning of a sentence. And it also knows what to speak next. Okay, that's essentially it is. All right. Okay, behind ChatGPT, there are other techniques than just using GPT-3. That's correct. If you use the playground with the same question task, you do not have the good results. Yeah. So there are quite a few things that they have done on ChatGPT on top of GPT-3 or 3.5, right? Like there are multi-level of trainings that have done on the GPT at the top of it. You can also create your own. I think they're about to open that playground. Okay, I have also applied there. So they're about to open the playground. So probably you can retrain the model and start using it over the API. And it can be trained for many more things than we had imagined. I never imagined that such kind of model can be retrained. Okay. Now, coming back to it, a question is, what do you mean when you say that ChatGPT is mainly decoder transformer? So what does it mean is that you remember the transformer model, it has encoder and there's a decoder. They have taken only the right-hand side part of it, not the left-hand side. Okay. And whatever is coming from the left-hand side, they have made it like self-attention, right? And that's what it is. Okay, so I would strongly recommend you to take a look at this particular one. Okay, and this was attention. Okay, if you actually want to just go through it, probably instruct GPT is probably the best paper that is available as of today. Okay. This one. Okay, you can just go through it because ChatGPT is based on it. Okay, and of course the blog on ChatGPT could be the next thing. Okay, this is the paper on which it is built, and you can just go through it. Okay, though there are quite a few research, but I've tried to condense that in this talk. And yeah. Okay, now let me just pick next question. Okay, can we use this for classification of our defined classes? Of course, you can just put one last layer on the neural network after GPT, and then just retrain it quickly for your own defined classes. The only problem is that it is after, like GPT is opened and probably you can use GPT as is, but they have not yet opened ChatGPT in the same sense. Okay, but yes, you can just take the ChatGPT model and retrain it for your classes. Okay. I suppose bias correction would be a great challenge in order to adhere ChatGPT in real world application. That's correct. But the important thing you need to understand is if you go, if you go to the website, I saw that you can apply there in OpenAI. Okay, so that's where I had applied. Okay, now one of the things that I hear a lot is the bias, right? Bias correction, right? Yes, most of the models or most of the humans for that matter are biased. Okay, and like our bias is as much as the data set or experiences that we have seen. Okay, so yes, just like anything in the world which has intelligence, we might have biases. Okay, it may not be perfect balance. Like if it has seen more, you know, if it sees more buggy code, it will write buggy code. Okay, buggy as in code with the bugs. And yeah, basically a lot of bias correction has been done by retraining it over and over. And by the other thing that they have done is they have explicitly tried to first classify if the question is toxic or not. So it tries to avoid those questions which are toxic and so on. And there are a lot of work that has gone there in this. So there's a lot of you have to essentially the bias correction has to happen at all levels of the engineering. Okay, but while gathering data, while giving priorities, while giving sampling of the data, while training the model, and so on. Okay, so it should not just miss some of the important parts, thinking those are outliers if they are rares. Okay, so it's a hard question, honestly. It's a hard question, but they have done a brilliant job by hiring people, manually marking things good or bad, and utilizing minimal amount of data in order to do the toxicity removal and bias correction and so on. Okay, but yes, that'll remain a lifelong problem. And if somebody wants to do work on that part, that's going to be great. Okay, and all right, would it be correct to say that GPT is multiple sequential model in parallel with the context? Yeah, so GPT is basically a large transformer decoder model, large transformer decoder, like multi-layers of it, and lots of humongous size. So yeah, and yeah, so some parts of it can be parallelized, but some parts can't be parallelized. Okay, therefore it's sort of sequential. A question is it possible to use ChatGPT to create music from text prompt? Is it possible to use ChatGPT to create music from text prompt? Good question, but yes, you can train it. Probably that would be the things that people would do creatively. If you go to Magento and so on, people should be doing it. Okay, and yes, this can be this should be possible because if you saw the question in our discussion, it was able to, since it's a language model so far, it's not an audio model, so it did its job. It's a lyricist, I would say. When you want to create music, the ChatGPT so far is a lyricist, and it basically creates rhyming poems. Okay, it is only text-based language model. Please correct in the case of, yeah, it's basically text-based model so far. Okay, but it has a good understanding of the language. Okay. It also has a good understanding of the code because it has seen lots of code, and code is essentially tokens. And yeah, what kind of matrices can be defined to evaluate the effectiveness of the model? Okay, so yes, that's again a hard question. The way they did 2 ways of it. Number one, they first created another model to come up with the metrics of this model. And that model was based on each words, whether they are matching with the target or not. So specifically the beam search that I talked about. So if you take a look at their paper, you will get an idea. So the way one is a loss function in these models. The loss function is maximum likelihood of the next word or maximum likelihood of the class that we are looking for. While in case of retraining it, the idea was coming up with the probability of the word that is defined by people. So again, it is there also. It is some sort of log loss kind of function. Okay, to evaluate the effectiveness. Okay. And usually in most of the cases, it's about whether the model is coming up with the answer in top 3 results or not. We call sometimes top K effectiveness. That's usually in the visual, but similar thing is true in some of the models. Okay. So Microsoft invested into OpenAI. How are Google, AWS catching up to GPT? I'm not sure about AWS. Okay. But I'm very confident about Google. They have built more similar model internally. I'm very confident because if you see most of the big, like the ChatGPT is based on GPT, which is based on transformer decoder model. And essentially that next word prediction is age-old problem. So ChatGPT was more or less utilizing the existing AI research. And most of that research actually came from Google, right? So it's very obvious to me that Google has all the data, all the machines, all the engineering scale. And they do have something called Lambda, right? But probably they are worried about bad press. And right, that's why they have not released. But I think there's a movement there. They are trying to do it. Okay. So the question that I'm asking more than how are Google, AWS catching up to GPT? Question that I'm asking is, how is the world catching up to GPT? Because when I say world catching up, it means that why aren't we making that model public? Okay. Yes, I know that it sounds like too much socialist. Okay. But I think in the time of open source, probably somebody needs to do it. Somebody has to do it, or probably there has to be some sort of new economy that comes into play. For example, I, let's say I come up with just like a licensing model. You must have seen the license, like GNU licensing model. So similar to that, let's say I train a basic GPT kind of a model, and then people who license from it, and they are bound to contribute to this model, probably in a year or two. Okay, so like that. So if a new licensing model comes up, a new economy can evolve rather than few companies monopolizing the data of the internet. Why not? Why not? That access to that should be with everybody. Like YOLO is public. YOLO, everybody has access to YOLO. Okay, so I'm very, very bullish about the fact that it should be available in some form or the another for people to use it. It should not be only inclusive, but a little more complex. You will have to basically debug. Okay, what's the best way to start learning GPT, ChatGPT? I think just start with the Instruct GPT paper, that the one that I mentioned earlier, and you walk backwards from that. Probably that would be the right way. Okay, and go through this presentation that we discussed today, this video probably at a later point in time, because there are many ideas that I talked about, and you can just look up those ideas to get more details on it. Okay, and you don't need to just finish entire of neural network from scratch and finish all of that. You can start with Instruct GPT. Then there are 3 papers on ChatGPT. The first paper is most important, and before that there is a paper on transformer, and before that there's a paper on backpropagation. So those are the few things I would recommend you if you are trying to learn. Okay, of course I'll try to publish probably a mini book on the architecture of ChatGPT, and yeah, my selfish interest is the more people are educated, the better it is for the world. And it should not become monopoly, or should not become property of 2 people or 3 people. It should be something that's available for everybody. Okay. GPT-3 has used a technique called diffusion modeling, and now a neural network called diffusion, which generates music. using images, right? Can we use this technique for next ChatGPT model? Yeah. So see, when we say, right, we call it stable diffusion, right? That's a model from somebody. Okay. So what they do is they take the model, they take like GPT model. GPT converts that into some sort of outcome, and then you can hook it with the images and like the other model, like the generative adversarial networks, and then it produces the outcome. So yeah, so there is a lot of magic that's possible, specifically because GPT or any such model does understand language. Okay, this is by far the most, you know, like the most complex system or most advanced system we have on the planet which understand language. Okay. So our question is, so it is much more intelligent than Alexa. Yes, definitely, I can bet on that. It is way more intelligent than Alexa or Siri. Okay. What's the role of DevOps in GPT? Right? When you're training or deploying any of the machine learning models, DevOps role is like predominant. Okay. Right? Whether it's optimizing the cost of training or optimizing the cost of deployment or making sure that deployment is going on and everything. So these are large scale systems, and DevOps or software engineering or system engineering, they play maximum role. Okay. I hope I was able to answer your questions. These were most wonderful set of questions I got. And stay connected with CloudxLab. There are a couple of courses that you can take at CloudxLab, which will make you up to the speed with machine learning as of today, as well as it gives you an environment where it gives you an environment where you can do hands-on. Also, we have very active Discord channel. So feel free to join the Discord channel posted on the YouTube chat. Okay. Wonderful. Wonderful. So I would love to thank everyone, specifically the audience, and I would like to thank my team to making sure, like helping me in putting together the presentation and organizing everything. All right, please join the Discord channel that is posted on the YouTube chat. And I look forward to see you guys in the next talk. I'll probably plan it out. And also once I publish my probably a mini book on ChatGPT, I'll be sharing with you so that you don't have to rummage around with the papers, because rummaging around through the various papers is fairly irritating, because most of the papers assume that you have the knowledge of everything else, and they just give the reference. And the people who are starting from scratch, it becomes very difficult for them. So, therefore, I think there's a need of a mini book on the ChatGPT. I'll be publishing it, so stay tuned. And it's so wonderful to see everybody that so many people are interested in understanding the architecture of ChatGPT. And thank you, everyone. Thank you, and have a great day.